everyone. Good afternoon. I guess the reason why I am the last one to talk is because I'm going to talk about something that's really big, the universe. So before we dive into our talk today, let's first look at how the ancient people view our universe. So this is what the ancient Celtic people thinks our universe is and where we are in the universe. The Hebrew people, the ancient Greek, and you're familiar with these, the ancient Chinese view. So I have summarized the ancient cosmology into 2 points. So the first is that the Earth is at the center of the universe, and we are fixed. And secondly, all the other celestial bodies, stars, moon, the sun, they are also fixed. And they are eternal, meaning that they never die, and they are at an infinitely faraway distance from us. This makes that these 2 points make me wonder whether we are arrogant or not, because the first point really is a very anthropocentric viewpoint. We are at the center, everything revolves around us. But the second one, admitting that we are actually ephemeral, whereas the celestial bodies last forever. It turns out that during the past 2 millennia, the observations of the sky has shown that these notions are just wrong. So I will take you through a journey where you will see these notions being dismissed. So I have a bad news for you, that we are not special, but I also have a good news for you, that nothing is really special at all. So our journey begins with the ancient Chinese historical record. So if you read the lines highlighted in red, you see it really is about a star that appears and then disappears. And this kind of object is known today as the supernova. So it is a violent explosion of a star that is about to die. So as a concrete example, this is a recent explosion of supernova in a nearby galaxy. The supernova is circled in blue. So you see that it's very bright. Its absolute luminosity is comparable to the brightness of the entire galaxy. And this clearly shows that the stars are not immortal. Stars will come and go just like us. So the next step, 1600 years later, almost, the guy Galileo, this is one of his manuscripts. So he is recording his observation of the planet Jupiter. And in particular, he noticed that there are several bright, tiny spots that appears to be appearing and disappearing on either side of Jupiter periodically. So what are these? They're actually the moons of Jupiter. And a closer view of his manuscript shows that at one time you may see one on the left and 3 on the right, and maybe you wait until the next day, you see 3 on the left and 1 on the right. So it turns out that some objects can orbit another celestial body. Not everything has to orbit the Earth directly. So this has displaced us from the center of the universe. We are not at the center anymore. Now let's look at this one. You see a bright star that appears to be moving really fast across the sky during different years. It has the name Barnard star. It's one of the fastest moving stars that we have known. And this kind of motion is called proper motion, the apparent motion of star across the sky. And it is discovered by Halley, the same person who showed the periodic nature of the comet. So Halley once figured out that, hey, some star can move across the sky. It immediately showed us that stars are not fixed at all on the sky. So it also showed us that the apparent position of different stars will change over time. So this is the Big Dipper, but as time goes by from tens of thousands of years before now and until tens of thousands of years afterwards, you'll see that soon it will no longer look like the Big Dipper anymore. The shape will change. So if stars are not immortal, if stars' motion is present, why should we believe that stars are also at an infinite distance from us? And really, the stars are not. So in 1838, the guy Bessel, he discovered the parallax of stars. So by parallax, it is the effect that if you look at something, and it is its apparent position relative to something that's even farther away will be different, depending on your point of view. So in this diagram, the Earth is moving around the sun, so the red star's position relative to the background stars will appear to be changing over time. And this kind of effect was suspected by ancient Greek people already, but it was not until the 1800s are the equipment instruments good enough to allow us to see this really minute effect. So it has shown us that stars are really not infinitely far away, but they're at a finite distance, and stars are at different distances to us. So let's again look at a famous constellation, the Orion constellation. So if you look at it from a different viewpoint, it will no longer appear familiar. Okay? So enough about stars. Let's move back to ourselves. Galileo just showed that we are not at the center of the universe, but maybe the solar system is the center of the universe. Who knows? So Herschel tries to answer this question by counting the number of stars at different regions of the sky. So he basically counted how many stars are there in this direction and in that direction, and then plotted everything onto a graph. And he figured that, oh, there are almost an equal number of stars in all directions, so it basically showed that we are at the center of the Milky Way. However, he is wrong, because he didn't know that there are dust in the Milky Way that can block the starlight, so that he cannot even see stars that are too far away. So to solve this problem, the guy Shapley, he used something different. So if you could see at the center, there seems to be a collection of stars that is called a globular cluster. And if we zoom in, you will see it is made up of tens of thousands of stars, or even millions of stars. So this collection, the globular cluster, must be much brighter than an individual star. So Shapley counted the number of globular clusters in the sky and plotted their positions onto a graph. So the green dots showed the position of the globular cluster, and the yellow dots showed our position. So it is very clear that if we assume the globular clusters are distributed uniformly in the universe or in the Milky Way, then we cannot be at the center of the Milky Way. We are just at the edge of the Milky Way. Okay, we're at the edge, but maybe Milky Way is the center of the universe. In fact, by that time, people thought Milky Way is all there is in the universe. However, 14 years later, this guy Hubble, he dismissed that also. So you see an example of a variable star whose brightness changes over time. And this kind of star has a very nice property, is that if you can measure its period of change of luminosity, you can actually know how bright it should be. Now, we are observing on the Earth, we know how bright it appears to be. So this comparison allows us to have an estimate of the distance, because the farther away it is, the dimmer it would appear. So this guy, Hubble, he measured the distance to a fuzzy object in the sky that's called Andromeda. It was thought to be a cloud in the Milky Way, but he measured the true distance to it by finding several variable stars in Andromeda and figured that the distance to Andromeda is just so far away that it must be a separate galaxy of its own. And it turns out that nowadays we can see more galaxies with astronomical telescopes than we can see individual stars. So many galaxies outside. The Milky Way is nothing that is special. And only 5 years later, this same guy Hubble, having known that there are many galaxies in the universe, he measured the distances and the velocities of a number of galaxies and discovered Hubble's law, which basically says that all the galaxies nearby are moving away from us. And today, we can measure the velocities of a much bigger number of galaxies. And each white dot you see on this picture shows the position of the galaxy, and the curve shows the direction vector of those galaxies. So many galaxies, they're all moving, nothing is at the center, and nothing is stable or eternal. And we are just one very tiny dot on this vast map of the universe. So maybe the really sad news that I should bring you is that the world is big, and we can never know its completeness. However, the good news that I really want to bring you is that our mind is bigger, so that we can try to understand. Okay, thank you.